Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to the series of the lectures of 10th class maths. We have discussed the basics of sets in our last class. That is, we have started with the definition of sets. We have discussed a few examples of sets. Then we have seen the two different forms, that is the roster form and the set builder form. Right? Then we discussed about belongs to, does not belongs to. Right? We have seen that if an element, for example, if A is a set such as 1, 2, 3, 5, 7, right? If I want to tell that 3 is an element of A, then I will represent it as 3 belongs to set A, right? Is it clear? Then what if there is some set such as 1, 2, 3, right? If I want to tell that this set is a part of this set, right? What is that I have to write? Is it clear? Hope you can understand. If I want to write this whole set is a part of this set, then I write it as B is subset of A. This is subset symbol. It is nothing but an extended C. You can remember like that. B is subset of A. Clear? Which means B is a part of a set A. Subset. Is it clear? B is subset of A. Is it clear? Where this is the subset and this is the superset. You can remember like this. Is it clear? Let us have one more example. P and Q. If P is some set having alphabets A, B, C, D, E and F. Is it clear? Then let me have one more set Q which has some C, E. Let us have only two elements. Okay. Is this set a part of this set? Isn't it? C and D, there are two elements. Then I can write it as Q is a subset of P. Is it clear? Where Q is a subset and P is the superset. Hope you can understand. Is it clear? For example, if I have this big set 1, 2, 3, 5, 7, then how many subsets can I get? Is it clear? Let us have a simple example, that is A sum 1, 2, 3. This is some set, it is a simple set. How many subsets can I get? I can get a single one. Isn't it? Can I get it, right? And can I get a 2, right? Then next, can I get a simple 3, right? The next 1, 2, isn't it? The next 1, 3, the next is 2, 3. These are different sets. I can also write it as 1, 2, 3. Right? Every set is a subset of itself. Don't forget to write that. Every set is a subset of itself. This is a subset of this set. Is it clear? How many sets did we get? 1, 2, 3, 4, 5, 6, 7. Right? We got 7 sets for 3 elements. Wait there itself. Let us have one more definition. That is a null set. What is a null set? Null. Or I can also call this as empty set, or there is one more name called as void set. Is it clear? An empty set, you can identify the definition, right? An empty set is nothing but an empty set. It doesn't have any element. This is usually denoted by phi, Phi. Okay, whatever you pronounce it, it is Phi, phi. Okay, phi, which is nothing but an empty set. Is it clear? Why did I tell here? It is every set has a subset which is one empty set. Whether he define it or he doesn't define it, remember every empty set is a subset of every set. Is it clear? Once again let me tell. Every set is a subset of itself. That is one statement. And one more statement is null set is a subset of any set. Is it clear? Totally how many sets did we get? 1, 2, 3, 4, 5, 6 and 7. 8 sets we got here. 8 subsets for a single set, that is having elements 3. Right? Then let me generalize that number of subsets is equal to 2 power n. Is it clear? Is it right? Right. See here. Here there are 3 elements. What about if I have 2, 4? We can generalize it. Let me take an example of set having 2 elements. Let us have, what are those? Let us take some element A having, some set A having 2 elements 1 comma 2. Let us write what are the different subsets. 1, right, 2, then next 1, 2, then one more is empty set. Is that right? How many sets did I get? 4 sets. If you generalize here, 2 elements are there. Then 2 square, it will have 4 subsets. 1, 2, 3 and 4. Is it right? Did you understand here what all we discussed here? One is what is subset, right? If some set is a part of this set, this can be called as subset. Okay, and this will be called as superset, right? In general, it is called as universal set. Universal set is for these all sets. I have started from this thing, from this to this, what all sets are there, right? These all sets belong to this particular set, right? Is it clear? For example, if we consider what all the objects, this board, this me and everything, the whole universe consists of we all things, right? Including me, you and everything. We are all a part of a universe, right? Here also these all sets are a part of this particular set. That's why we can also call this as universal set. Usually universal set is always denoted by mu. Remember that, or else most of the people based on the application and based on the chapter we discussed, this can also be. Okay, did you understand what all we discussed? Subset, universal set, right? How many number of elements in a set, right? Now let us start our discussion with a union of sets. Okay, what do you mean by the term union? Let me take 2 different sets, that is, let me take a set A, that is 1, 2, 3, 4, 5, 6, 7. Let us take up to 7. Okay, let me take a set B, which is 2, 4, 6, 8. Okay, then let us assume that this A and B are subsets of some universal set 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, is it clear? Right? Then the union of sets is defined as A union B, that is equal to, see here, it is denoted by union. What do you mean by the term union? We know that if we combine everything, we tell it as union. Union of 2 elements or else 2 different kinds of objects. Here also we have 2 different sets. The union is the combination of all the elements of these 2 sets, right? What are the elements here? 1 to 7, here 2, 4, 6, 8, right? What are the elements? Let us write everything, that is the union 1, 2, 3, 4, 5, 6, 7 and 8. If you observe, I have written the common elements, that is 2, 2, 4, 4 only once. Why? Since whatever, how many number of elements it might be, these are the same elements which are repeating, isn't it? That's why I have written the same element only once. Is it clear? Did you understand with union? Now let us represent it in a different way, that is a set A, a set B, right? Let us assume I have a set A, which means this is a kind of a box which consists of these numbers 1, 2, 3, 4, 5, 6, 7, 8. Oh, up to 7. Is it okay? Let me have one more set B consists of these number 2, 4, 6 and 8. Right? This is a set A and this is a set B. This is included from a box U, which is a universal set, right? These both are a part of this universal set, right? Let us write the common number first. What are the common numbers here? 2 and 2, 4 are the common numbers in both the sets. Let me write it here because this part is a common for both the things. What are the left out elements in the first set? That is, except 2 and 4, we have 1, 3, 5, 6, 7. 1, 3, 5, 6 and 7. Right? Similarly, what are the elements other than 2, 4, those are 6 and 8. Is it clear? Now the union of these both is always given as like this. This a kind of pictorial representation, right? You have to represent it here. A union B is nothing but this is a part of A union B. Is it clear? This is how we draw a Venn diagram, right? This is actually called as Venn diagram. Venn is nothing, not that WHEN. It is VENN, which is the name of a scientist. Is it clear? This is how we represent a combination or the union of two different sets, right, in a pictorial representation. That is a kind of a diagrammatical representation. Okay, that is called as Venn diagram. Let's recall everything again. See here, let us assume two sets, that is A is one set and B is one set. To find the union of two sets, I have to check which are the common elements, except that, we should not repeat the same element again and again. We should write each and every element, right? Even if the elements are repeating, we have to write it only once, right? This is how we represent A union B as a Venn diagram. Okay, now let us go to intersection. Okay, let's do that. See here, intersection. What do you mean by the term intersection? In the different concepts we have used this term. An intersection is always can be called as a common point, right? That is, here the intersection of two sets is always defined as A intersection of B, right? The symbol of intersection is also opposite to our union, right? We have to check the common elements between the first element and the second element, first set and the second set. What are the common elements here? 2 and 4. Is it clear? These are the two common elements in A and B. Is it okay? Then how to represent them in a pictorial graph? This is A, this is B, isn't it? This is under some universal set U, right? Now if I have a set A, let me consider this as horizontal line, then a set B, let me consider it as vertical lines, like this. This is set B, this is set A. Is there anything common between these two sets? Right? If you observe, there is a common point in between both of them, that is this kind of area, the horizontal line and the vertical line. They combine together, that area is A intersection B, which means the area which is common between A and B. Okay, we can write the numbers there also. What are the common numbers? 2 and 4. What are the numbers left remaining in the first set? That is 1, 3, 5, 6 and 7. And in set B, what are the numbers left? 6 and 8. Is it clear? Once again, let's recall that intersection of two sets is always given by the common elements of the two sets, right? A is one set, B is one set. What are the common elements here? 2 and 4 are the two elements which are common in both the sets. Is it clear? This is how we represent it pictorially. This is again Venn diagram. Remember, you should be able to draw Venn diagrams for not only two sets, you should be able to draw for 2 to 3 sets also. Okay, now let us move on to the next difference of sets. Okay, the difference of two sets, that is, we have seen, we have used that word difference in many places, that is the difference between two elements or the difference of two numbers. That is, if I assume the difference between 3 and 1, what is the difference? It is 2, that is 3 minus 1 is 2, right? Which means we have to subtract. For example, let me give you an example. If this is some kind of cake, right? If I want to remove this particular part, is it clear? This is the whole part, right? If I want to remove this particular part, right? What is the part left here? That is the remaining part. That part is separated. That is, from this whole part, if I remove this, this will be my A. That is the common part, whatever it is there. This part has to be removed, which is common in both the things. Here also, the difference of two sets is defined as A minus B. that is written in this way, that is 1 2 3 4 5 6 7 minus 2 4 6 8. What are the common elements here? That is 2 2 4 4 6 6. What are the elements which are left in the first set after cancelling? We get them as 1 3 5 7, isn't it? Similarly, let us do for b minus a, that is 2 4 6 8 minus 1 2 3 4 5 6 7. We have to cancel the common elements, that is 2 2 4 4 and 6 6. Is it right? What are the elements which are left here? Those are 8 in the first set, right? Did you observe, did we solve for A intersection B, B intersection A or B union A? Why didn't I? Because whether the common element or the union element, they are always same. Is it clear? But here the A minus B is not at all equal to B minus A. If you observe, there is not even a single element common in both the sets. Okay, let us do it pictorially. That is, see here, let me consider two sets, that is A, B, right? What is A minus B? B should be completely eliminated from B except the common part in A and B. I have to draw everything. Is it clear? That is A minus B. What about B minus A? The elements or the common area with A, except that the remaining should be taken, right? Is it clear? Now see here, did you have, do you have any common area between A and B? Right? There is no common area between A and B in the A minus B and B minus A, right? What is A minus B here? A minus B is this, B minus A is this part. Is it clear? Right? This is how we will draw different Venn diagrams and everything. You can even remember here, A minus B and B minus A will never have a common element, that is their intersection is always a null set, which is fine. Okay, did you understand till here? Right? Let us discuss few more concepts of sets and everything in our next session. This is for today. Is it clear? Thank you.